Hello everyone. In this video, we will be covering the concept of hoisting in JavaScript. Don't you worry if you don't know what hoisting is right now, as you will understand the concept by the end of this video. It's something that's very important to know as it'll help you better understand how variables and functions work, which in turn will lead you to write better code and give you an easier time when debugging your code. I will be adding some useful links down in the description if you want to continue diving into this concept, and the code will also be hosted on GitHub. Without further ado, let's get into it. All right, so to start, I have an index.js file that I will be running within Node. So if you want to follow along, please just create a file, and then I will be using the terminal here to run the code in the file. All right. So to start, let's look at a quick definition of hoisting. And we can define hoisting as the process of saving the declaration of functions and variables in memory before the code has ran. So there is quite a few large words here, like declaration. And to start, let's confirm what a declaration is of a variable. So if we write out a variable, and I'm going to do var name equals Marcus, there's actually two things going on here. There is what we would call the declaration of saying, hey, we have a var called name. And then there is the initialization, which happens on the right side of this equal sign, where we're saying this var name is equal to Marcus. So if we want to break this up into two parts, we could do this, and we'll say this portion of declaring the var name is the declaration. And then we'll say the part of assigning the name to a value, in this case Marcus, is the initialization. So this is super important to remember because when we are hoisting variables, as we'll see in some examples, we are only hoisting the declaration of variables and not the initialization. So let's go ahead and see that in action. So let's begin by demonstrating hoisting within variables. So I'm just going to write a comment here and I'll say hoisting variables, and this will be var, let, and const. So we'll start with hoisting var. And to do this, I'm going to write out a function where I'll be demonstrating our hoisting here. So I'm going to do function print name. And within print name, I'm going to declare a variable, and similar to up here, the variable will be name Marcus. Let's just scroll down so this is the only thing we see here. And let's just print out our name. So if we go ahead and we run our function, we should see the name getting printed. Perfect. We see our name getting printed here. Now, this code runs in asynchronous order. What do I mean? I mean, we're declaring a name here on line 11, and then we're printing out the name on line 12. But what happens if we try to print out the name before we have declared and initialized our variable? So let's go ahead here, put the console.log of name before, and let's run this code. So you can see here that we get undefined. And why is this happening? Well, if we go back to breaking up our variable declaration or of name into the two parts, the declaration and the initialization, we can see here that if we end up printing out name, if we print out name before it's been initialized, what do we think the value will be? So right now we just have a var name that's not set to anything. What do we think that will be? So let's go ahead and run it here, and we get undefined. But then if we print out this value after it's been initialized to Marcus, what do we get? We get Marcus. So what's actually happening if we print out name before the variable declaration? We get the same result of undefined as we would get if we printed out directly after the declaration. So why do we get the same output with our console.log in two different places? So what JavaScript's doing when it's declaring the local memory for this function, because if you remember from our previous video on variable scope, we know that vars are scope to the function, so they do not exist outside of the function scope. So what happens is when JavaScript is processing this function's memory, it's going to quickly run through the code that's there. It's not going to execute it, but it's going to run through the code and it's going to look for any declarations for vars specifically. If it sees a declaration for var, it's going to save that declaration in memory within the local scope. So before any code has ran, we know that there is a var called name that has been declared. It has not been initialized, that's why we get undefined, but it has been declared. And that process is what we would call the hoisting of the var keyword. So we'll get into let and const, and you will see how that functionality differs from var. All right, so let's get into the hoisting of let and const variables. So we will be grouping these together as the functionality of how they're hoisted is very similar. So I'm just going to copy this piece of code here, and I'm going to comment out this one, and we'll say hoisting of let and const. So what we're going to do to start is we're going to declare a let variable of name, and then we're going to initialize it to Marcus. So as we did before, we'll print this name out to the console. So let's go ahead and run this code, and you can see as expected we get Marcus. Now what happens if we try to print out name before it has been declared and initialized? We run into an error, and we get the cannot access name before initialization error. So what's happening here is JavaScript does not allow the let keyword to be accessed before it has been declared and initialized. So if we try to print it out beforehand, nothing happens. And it's similar with const. So if we go here and we just cut this out and change this to const name equals Marcus, and we cannot have an empty constant, and I'll show you guys that quickly. And that's because as constants cannot be reinitialized, they have to be initialized to start. So if we run this code here, we get missing initializer and const declaration. So that's a little side note, but let's assign this name to the name of this constant to Marcus. And let's just clear our console here, and we get Marcus as expected. And then if we try to print out the name before the declaration and initialization of this constant, let's see what we get. We get another error again. Cannot access name before initialization. So right there, we can see how let and const differs from var in terms of how they are hoisted. And this is important to know, as if there are var variables declared in your code, you could get some funny functionality if they're accidentally accessed before their declaration. Whereas if you use let and const, you can rest assured that those variables will only be accessed where you think they will be accessed, and that's after they have been declared and initialized. Now that we have covered the hoisting of variables, let's get into the hoisting of the two kinds of functions we have in JavaScript. One using the function keyword and the other one being arrow functions. So I'm just going to copy this down once again and comment out this portion, and we'll say hoisting of functions. So for our first example, we will be using the function keyword. And to do that, I'm going to declare a var and give it the value of Marcus. And I'm going to redeclare or reinitialize this var to a function, which is going to be called getNewName. And at the top here, we're actually going to write out this function, getNewName. And this new name is going to return Roland. And then what happens here is after we have reinitialized our name to our new name, we're going to print out our name. So let's go ahead here and run this code. And we can see here we get Roland. And this code's pretty simple to understand. We're declaring a function called getNewName. We're then declaring a variable called name and initializing it to the value Marcus. We're then going to reinitialize this name to the result of getNewName, which returns Roland. And then we're going to print out this name. Now, this code runs as expected since our function is declared before it is called. But let's see what happens if our function is declared after it is called. So it's called here on line 29, but it's declared down here on line 33. So let's see what we get here. You can see we get Roland again. So our code has ran exactly as it did before. And the reason for that is that function definitions are also hoisted. So JavaScript, similar to vars, will look into our code before it is executed. It'll look for any function keywords and it will save that function declaration inside of memory. So once that function gets called, JavaScript will know that, hey, getNewName is a function, and it will go ahead and execute that function and run the code there. So this is very good to know because if we're writing long functions ourselves and we want to have smaller functions inside of it, and we also want to keep that away from our code, we can declare all of our functions at the bottom of the scope away from our code, and we can trust that they will run as expected while keeping our syntax a lot cleaner. So this even works if we have the return keyword on a function. So we can return name here, and instead of printing out the name, we'll print the result of print name. So the result will be the value of name that gets returned. So let's go ahead here and run this in our console, and we can see we get Roland as expected. So as we know, the return keyword tells JavaScript that this is going to be the last piece of code that gets run within our function. But even after that, JavaScript will have saved our function declarations. So once that function gets called, it will know to go inside of that function and run the code that's there. So this is super great to know, as it allows us to better organize our JavaScript code and functionality. All right, so now let's get into the last part of our hoisting examples, and this will be the hoisting of arrow functions. So I'm just going to copy this code and let's comment it out here. Hoisting of arrow functions. So what we're going to do here is we're going to declare a constant, get new name, and we're going to assign it equal to an arrow function. And because these are arrow functions, we'll make our syntax a little fancy here. And we will assign the value of new name equal to this arrow function, which returns the string Roland. And as you can see here from our syntax highlighting and with our previous knowledge of how constants work, this is unreachable code and it will not run. So if we want to go ahead and run this code, I think we know what will happen, but let's go ahead and do it anyways. I'm actually just going to get this back to a normal print, and we'll just console.log the name. And we get a reference error. Cannot access new name before initialization. So the reason this is happening is because arrow functions, by their nature, are anonymous functions. That means they do not have a label or a declaration attached directly to them. When we declare an arrow function, we're assigning it as the value of usually a constant. In my experience, I've only ever seen arrow functions be assigned to the value of a constant or an anonymous function that we're passing as an argument to another function. So because it's a constant in this case, we cannot access it before it has been declared and initialized. So let's just go ahead and move our function, our arrow function declaration and initialization to the top and run this code. And we can see it works as expected. Thanks for sticking with me until the end of this video. I do have a link to the code down in the description, as well as a few other useful links to continue your learning of this topic. Thanks again and have a great day.